Alright, hey there guys, and welcome to this video on ionic equations. So in this video we are going to examine exactly what an ionic equation is and how it is to do with oxidation and reduction. We're also going to be able to work out the full ionic equation given a chemical equation, right? And then finally we're going to be able to state the ionic equation based on any neutralization reaction of an acid and alkali. Okay, so let's dive straight in right now. Alright, so let's take a look at a chemical reaction, which is, of course, a displacement reaction. Okay, if you don't know what a displacement reaction is, then please go and have a look at my videos on those, and that will sort you out. But I'm going to assume you know exactly what these are. So, what we need to do is we need to decide what is being oxidized and what's being reduced, right? The way to do that, really, is to consider what ions do we have, okay? So, if I look at chlorine, well, this is a chlorine molecule, okay? It's an element on its own, so it has a charge of 0, right? It's not an ion, clearly. It's a covalent molecule anyway, so we know that. Now, sodium bromide is ionic. Sodium is in group 1, so it has a charge of +1. Bromine, is in group 7, so bromide has a charge of -1. It gains 1 electron. And then let's go over to the right-hand side. Sodium, same thing. Chloride, -1, because it's in group 7. And now bromine has a charge of 0. And so you can see that certain things have changed their oxidation states, or they've changed the amount of charge, and certain things have not. So what I'm going to do now is I'm going to write out the actual ions involved. So chlorine is not an ion, okay? However, chloride is. So Cl-, okay? And on this side, that comes from chlorine, okay? And what I meant, by the way, by writing the ions out, is anything which has changed charge, I'm going to write out what it is before and after, okay? Right, so sodium is +1 on the left-hand side, +1 on the right-hand side. I'm not even going to bother writing it because its charge has not changed. And bromine, well, it's bromide on the left-hand side, which is Br-. And be very careful here because I actually have 2 of them. So that's 2 Br-. Okay? And then on the right-hand side, what do I have? Well, I have Cl-, but I have 2 of those, okay, because of this. And bromine is Br2. Okay. Now, this is actually our full ionic equation, right? So this is our ionic equation because we have said what, basically which ions are changing charge, and we've balanced those and put them together. Notice that we haven't written any electrons. If you have seen my video on half equations, you'll notice that in that video we have a look at each one, so the reduction and oxidation separately, and then combine them. This is a quicker way of doing it if you only want the ionic equation. We could have broke this down into half equations, but I haven't bothered because I don't want the half equation in this case. Okay, so actually pause the video and have a go at this question. Try writing the ionic equation for this question. Right, so welcome back. If you did have a go, I'm going to go ahead and do it for you now. So let's actually label the charges on everything that we have here. So magnesium is in group 2, so it's going to be +2 because it's in an ionic compound. Oxide is always -2. Alright, now what about sodium? Well, sodium is actually an element on its own in this case, and so it has a charge of 0. That's something that people miss. Don't have a look at the metal and just say, oh, it's definitely +1 because it's in group 1. If it's on its own, it's 0, and that's the same for any element. But now, on the right-hand side, sodium oxide. This is now an ionic compound, and so we can say that sodium is +1, right? Oxide is still -2 because it's still in an ionic compound, and magnesium is on its own and it's now 0. Okay, so now let's write out everything that's changed charge. Well, what hasn't changed charge? What hasn't changed charge is the oxide, right? -2 and -2, so I'm not going to bother writing that one. Magnesium, though, I am going to write. It's a 2+ ion, so I'm going to write magnesium 2+. Plus. And sodium, right? Now, even though this is not an ion, remember, because it changes charge, I'm going to write it. And there are 2 of them, so I'm going to write 2 sodiums. Makes. Now, what do we have here? We have 2 sodium ions because they're +1. So that's sodium +1, or just plus. And there are 2 of them, right? Be aware that I've written a 2 in the front because each ion is separate. I don't go like this. Na2, because that tells you that those sodiums are bound together, which actually in solution they're not, right? And so it's actually 2 sodium ions like that, and then We obviously ignore the oxide, and magnesium is now on its own and it's not charged, and like so. And so this is our full ionic equation. Okie doke. So that's all well and good. Finally, in a neutralization reaction between acid and alkali, the ionic equation is very, very predictable, right? This is absolutely true. And we can work it out from a simple example. So let's have a look at one now. So you have hydrochloric acid plus sodium hydroxide makes sodium chloride and water. And so what I'm going to do now is I'm going to go through and label things which are charged again, right? So, by the way, this means things which are charged in solution. Bearing in mind, even though HCl can be a molecule, right, you put it in solution, it's hydrochloric acid and it fully ionizes, so it is ionic. Okay, so hydrochloric acid has H+, so that's +1, and chloride is minus, so that's -1. Sodium is +1, right? And now hydroxide is an ion on its own, which is -1, okay? Right, now, what do we get on the right-hand side? Well, you have sodium chloride, which is an ionic solid, which is an ionic compound. In this case, it will be in solution. So, sodium is +1, and chloride is in group 7, so that's -1. And then water, okay? Water is a covalent compound, which means water has an overall charge of 0. There are no ions in water, right? Basically, if we have a look, water has come from our hydrogen ions and our hydroxide ions. The sodium and the chloride ions actually haven't changed. And so we can actually write out a very simplified ionic equation, which I'm going to do right now. So, what has not changed charge? Well, chloride is still chloride. And sodium is still sodium. Okay, so the only things which have changed are hydrogen, which is H+. So I'm going to write H+, plus hydroxide, which is OH with a charge of -1, so minus, forming a neutral, hence the word neutralization, compound, which is H2O, or water. And so for a neutralization, we end up with just saying H+, which, as you should recall, is the the acidic ion. OH-, which you should recall is the alkaline ion, forming water, which is neutral. And that is why this is called a neutralization, right? And this is the same for any acid and alkali that you pair together in solution, right? Strong acid plus strong alkali in solution has the same ionic equation, right, for neutralization. So H+, OH-, H2O. Okay, so that is all well and good. We're going to stop there. I hope that did make sense. If you're still concerned about anything, feel free to put a comment in the box below or send me a direct email and I'll get back to you. But as usual, please like and subscribe because that really does help me out. And I look forward, of course, to seeing you in the next video.